Good evening, everyone. Am I audible?
Yes, ma'am.
Thank you. Let me share my screen. Okay. Screen is visible, right?
Yes, ma'am.
Yes.
Okay. So today we'll be starting with a dictionary, one of the data types that we have, kind of data structure, just like a list, tuple, etc. And then we'll discuss on iterators, generators, and also some of the functional programming part like zip function, filter, map, and enumerate. Okay, we'll start with dictionary now. So hope you I hope you have gone through the list and tuple part. So in a list, you might have seen how we can store a collection of numbers or strings or etc. into a single object, right? And if you want to store something in pairs, the data in pairs, then you can use dictionary data structure. So it's similar to the dictionary that we have normally, like we have the words and then the meaning, right? Words and meaning corresponding to word, we have the meaning. Or in real life, we can take example like if you want to store all numbers and names, you can use dictionary. So to store something in key value pairs, we use dictionary, and we'll see how to define an empty dictionary, how to create dictionary, and how to add, remove, etc. Different manipulations in dictionary. So first of all, let's see how we can define an empty dictionary. So you can use this curly braces, just like in list we have square bracket, and for tuple we have round bracket. For dictionary we have this curly bracket. So if you write like this, so suppose this is the D is the name of the dictionary, and then this is representing an empty dictionary, the curly braces. So if I print this, I'm gonna get just empty dictionary without any elements. And the other way by which we can define an empty dictionary is using this particular function called dict. So you call the dict function assigned to some variable. Now you get an empty dictionary D. So these are the two ways by which you can define an empty dictionary. Now, how we can create a simple dictionary with the elements, with key value pairs. So the key value is separated by a colon, and the elements are separated by comma normally. So here you see we have name as key and value is some age. Okay, I'm thinking this is age. Now this particular name is associated with this particular value 14. Similarly, this one is associated with this value 15, and this is for this particular value. So this particular part, the first part is called as key and the second part is called as value. Okay, so we have how many key value pairs? I'm audible, right?
Yes, ma'am.
Okay, so we have
Yes, ma'am.
three key value pairs, right? This is one key value pair, this is the second one, and this is the third one. Getting it? So how many elements we have in this dictionary? Three elements. Yeah. So next part we'll see how we can add a key value pair to an existing dictionary. So we have this D with key value pairs, and now you want to add one more key value pair to this dictionary. For that, what you have to do? In list, if suppose we have L, then how will we add element to a list? We'll use append, right? Or how we access the elements of a list? We have to use indexing, correct? But here, instead of position or index, for dictionary we have something called key, right? So to add one more key value pair, what you can do is can use d of key equal to then the value. So if you do this, Then if you see our dictionary, the first line, focus on the first line. So we already had these three elements, these three key value pairs. Again, we have added one more. So live in and 22 is the value. Getting it? So this is how we add a key value pair to an existing dictionary.
Yes, ma'am.
Yeah. Now let us see some modification on this dictionary. So in this line, what I have done, I'm trying to add live in again with a new value 45. Okay. So when I add live in with 45 and print it, you see the second line. Here I am printing that particular dictionary. The second line of output corresponding to this. So here you see live in is not added again. Rather, whatever the value of live in, it got replaced by the new value. So from this we can conclude that the key should be unique, right? We can, when we again try to add the same key with some different value, what happens is it's not getting added, rather the value of the key get updated, right? Here again I'm changing the value. So basically whenever you try to add the same key, same element with same key and a different value, the value corresponding to the key will get updated. That's why we are getting 45 here and 14 here for live-in. Okay. And now, so we should remember that keys should be unique. Keys should be unique. Okay. And value, it can repeat. So when I add 14 here, so we have 14 for Amrita and for live-in, right? That is fine. Value need not be unique, but keys should be unique. Here again, simply updating the value. So, okay, what you learned from this particular exercise? Anybody?
Ma'am, could you repeat your question?
What you learned from this particular exercise or the cell?
Updating or mutability of dictionary.
Okay. So, what else? What about the uniqueness of key?
Keys could be unique, ma'am. They should be
And
unique.
key value should be unique. Key value should be unique.
Yeah, keys should be unique. The value can be repeated, right?
Yes,
The
ma'am.
value can be anything, na list, tuple,
Anything.
sets,
Yeah.
value.
Yeah. Value can be anything. And the data type of key we'll discuss later, okay? What can be the data type for key? We'll see later. Now, this is same how to update a key value pair to an existing dictionary. So here we have a dictionary with 0 as key and value as again 0. Here with same value, value of key is similar to what we have here, and this is 2 and 2. And if you see the output here as D, this is 0 1, which is the second one, because this will get updated to the latest value for key 0, and next is 2 2. Okay.
Ma'am, over here, could you repeat why
And
only zero is
this is
mapped to one? Why not zero? Like instead of zero one, why isn't there zero zero and two comma two? Sorry, two is two.
Yeah, so this is the first assignment. So this one comes after this, right? So the latest value for 0 will be the output. It is
Okay,
following the insertion order here.
okay, I understood, ma'am. It's
Yeah.
like assignment values, like
Mm.
okay,
You
yeah,
can think it of like d of 0 equal to 0 first, and the next line is d of 0 equal to 1.
yes, ma'am.
Yeah. And the next point, keys cannot be duplicate. Key should be unique. Okay. So these can be the data type for key. It can be an integer, it can be a string, it can be a tuple, float, anything. So the rule is it should be immutable. Key should be immutable. Okay. Immutable means what? We cannot change it. Tuple we cannot change, right? Once we create a tuple, we cannot add or delete. So, can we have a list as key for a dictionary in that case?
Could you repeat your
Can we
question?
have a list as key for a dictionary?
No, ma'am.
No, because list is mutable.
Yes, ma'am.
Yeah. So you may
But ma'am, because list is mutable.
without list.
No, list is mutable. That's why we don't use
Ah,
it as key.
right, right. So you will also learn somewhere about hashable. Like these keys, whatever that we put here, they should be immutable and they will be hashable. So what is hashable means? For now, you just understand it's like a unique fingerprint, or whenever we create a hashable object, it will get a unique code. Okay, so there is some function called hash code. So it will get called and a unique number or unique ID kind of thing will be assigned to it, which means they are unique now. So that is called as hashability of the data types. You just have to understand the basic part, don't have to understand how it is done and all, but still. So for now you understand that key should be immutable and these are some of the type that we can have for key. Now,
Ma'am, can we say hashability is like in a tuple if there is a list and
hmm,
since tuple are immutable, but we can change the lists inside by accessing the lists so that in
hmm.
that way hashable can be defined.
No, so in that case we cannot use it as key because it's not hashable, tuple of list. So even though we can use tuple as key, we cannot use tuple of list as key because still it's mutable, right? As the list is mutable inside the tuple, so it's not hashable.
Uh, Ma'am, I got confused. I'm
Yeah,
asking about hashability, ma'am, not about keys. About the definition of hashability.
yeah. So when we can, so if you okay, right, simply what we can do is you can call the hash function over tuple of list, and then you can see whether it generates the code or not, hash code or not. I think it's given in some one exercise, I guess, in the portal. We have a table somewhere. Mm, I forgot where it was. So you will see that if you see which are hashable and which are not hashable, uh, tuple of list cannot is not hashable because the list itself is mutable. So we cannot generate, we cannot call this hash function over that. Getting it?
Ma'am, hashability is always associated with immutabilities.
Correct. So as list is mutable, even though tuple is immutable, when we have tuple of list, now it's not hashable. Don't think much about it. Just remember that list is mutable, and if we have a tuple of list now, As list is mutable, now tuple of list is not hashable. Okay.
The wording, could you just correct me if I'm wrong? If tuple has a list, then that tuple is hashable or not hashable, ma'am?
Not hashable.
Ma'am, in lectures they said it is the hashability is meant that if we are able to change the list, since list is mutable, so tuple are not mutable. So the, that sort of variation is known as hashability. I think that's what I've listened.
No. If tuple of normal integers or something, then it's hashable. But if it is containing a list, then we cannot hash.
Okay, ma'am, please continue. We'll
Yeah,
discuss it later.
yeah, sure. Now we were here. How to check if a key is present in a dictionary? So normal, we have this in operator, right? With the same in operator, we can do that. So here you see we have a dictionary with these values. I have repeated this again. Okay, let me remove this to. So we have three keys. So is three values. So here I want to check whether this particular key is present in our dictionary or not. So I'm checking if Babu is present in using an operator in dictionary D. Then simply print the value of that particular key. So D. So how we can access? You just have to use square bracket, and inside that you pass the key. Just like in list we pass the index, here we pass the key. So here D of Babu will get output as 14 because the value associated with Babu is 14. So this is how you can check whether key is present in dictionary or not. And then next is how to delete a key value pair from a dictionary. How to delete. So we have this del function, operator. So using that you can delete. So this is our dictionary, and here I'm deleting first key is D of Amrita. So when you delete a particular key, which means it is going to delete the value as well, right? So this is deleted, and for Babu this is also deleted, and finally we are printing the dictionary. So only Kavita is present in the dictionary. Is that clear?
Yes, ma'am.
Yeah.
Yes, ma'am.
So another way is if you go to documentation, you'll see these functions. So first one is pop. So when you call pop, you have to pass the key. Okay, so d dot pop, and then you pass the key. This will also delete and return the value that it deleted. So if you print this, what will you get? As it is returning, so you will get the value that is associated with the key Babu. So 15 is returned. So we are printing that here. That is for line number 2. And for pop item, so the pop item in versions above 3.7, including 3.7, it will delete the last one, last element. So it's all got deleted. Babu got deleted, Kavita got deleted by pop item. So the remaining one is Amrita F14. So that is what the final one. Any doubt you have?
Ma'am, once could you repeat the checking function or like membership check function, ma'am? When I'm coding, I'm getting a false value.
Clear, right?
Ma'am, I have done D of Babu in D. Not I've not written if loop. So am I right? Like I've not written if
Yes,
loop.
sir. You have not written if, but still trying to print D of Babu, right?
Yes, D of Babu in D.
Okay, I got it. Just the boolean value you are trying to get.
Yes, ma'am. I'm getting a false value.
Maybe you have deleted before. Okay. Wait. Okay, what you are doing is D of Babu in D, right? So that means 14 in D. So it is checking whether 14 as a key in D. If you want to check simply, if you want to get, this will return it true. So that way you are checking whether a key 14 is present in dictionary D.
Understood, ma'am. Yeah.
That's it. So I'll just change it so that I can share this collab with you guys. So where were we? Yeah, here. Here any doubt? Pop and pop item?
Ma'am, in delete also, I'm having a small query. Uh, since we are giving the D of Amrita, so it will delete 14, right? Will Amrita be retained?
No, 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 no. Every key value in dictionary is like they act like a pair. So if you delete the key, both key and value gets deleted.
Ma'am, if more than one values are there in like, okay, sorry, yeah.
Key should be
Understood, ma'am.
unique, right? Yeah, anyway.
Understood. Yes, please continue.
Yeah. Okay, then how to iterate through the keys of a dictionary. So, okay, let's see some of the outputs for this. After that, I'll see how to iterate. Okay. Command. So we have this function called keys, okay, that we can call on dictionary. So d dot keys, what it is returning. So d dot keys will return an object of whatever the return. If you see the return type, it is different. Kind of type of d dot keys. Okay, this the data type is dict keys. So what you have to do is you have to convert into list so that the output is a list now. So see the output here. When you call d dot keys, what you are getting is list of keys present in dictionary D. Okay, and when you call d dot values, this values function. So values function, you will get list of values of that particular dictionary. And when you call d dot items, so items means each key value paired together. So you will get list of tuples. Okay, so each tuple is a key value pair. This is each item means each tuple is a key value pair, and d dot items is going to return as a list of this particular key value pairs. So these are the important functions that we have in dictionary, and we have to convert this to list every time to get it in the form of list. Otherwise, the normal data type of, if you want to see the data type for d dot values, you can check it. So you see here, this is dict keys and this is dict values and this is dict items, and these are the object of these classes. But anyway, we'll change that to list and then print it out or use it anyway. Okay, is that fine? How we can access keys, values and items as it is in the form of a list. Is that okay?
Yes, ma'am.
Yeah. Now, using this, let's see what we can do, how we can iterate through the keys of a dictionary. So normally you might have already seen when we checked the membership of key in our dictionary, you can use a for loop like this. Just so when you use the in operator, it is going to access each of the keys of the dictionary, not the values. So for each element key in the dictionary D, we are just printing out the key. So that is why we get this as the output, the normal way. And you can also use our function d dot keys, which is also going to return the keys in the form of a list, right? So this will also give us the keys of the dictionary. You can iterate through it. Okay, similarly, what you can do?
Ma'am, in place of line 8 and 9, could you use X instead of key?
Yeah, you can use anything. This is just a name. Okay, this is a
Ma'am,
temporary name.
ma'am,
Yeah.
but
Yes,
someone
yes,
has
yes.
doubt, one doubt. She has message with for my team.
How am I saying tuple? Tuple what? 527. I didn't get this. Related to which part in type?
That the key value uh, they are presented in the form of a tuple inside the loop.
Okay, about d dot items, huh?
Yes, ma'am.
Okay. So that is how it is defined. That is how the items function is defined to return the value in list of tuples. It's like somebody wrote this function items, okay, for the dictionary class, okay, and the items function is going to return the key value pairs of our dictionary in this format. That is how it is defined in that particular function. Okay, this is not don't confuse this with the normal dictionary representation. This is how the return value of item is going to be. Getting it?
Yes, ma'am.
Yeah. So when you reach now week 5, right? Week 10, I guess, you will learn about object-oriented programming, about the classes, objects, everything. So there will be, everything will be clear by then. Okay, here what happened? So you can use any variable for this temporary purpose. It is just a representation of each element. Okay, need not be key. Now this is how we can iterate through the keys of the dictionary. And next,
Ma'am, for printing values, so we should C of X, can we write? C of square brackets of X. Will that print values in,
yeah,
in line 8 and 9?
right. Yes, that will work.
Okay.
So you see here that is same. How to iterate through the values of dictionary? Two ways. One which we will use simply a for loop, and we know the key, so we'll just use t of key. Okay, somebody asked now, right? Same. And using d dot keys also, we can do the same d of key. Instead of printing directly the key, now we are printing the value. So 14, 15, and 16 is getting printed here. Any doubt?
Ma'am, I can't get the difference between these two codes. I'm like they both are giving us synopsis.
Yeah. There is no difference. This is just the normal way of doing using a for loop. And now we have this keys function, which is going to return us list of keys. That's why we are able to use this as well. Anyway, you can do. Okay, no need to focus on one method.
So, ma'am, does that mean we can use D dot keys or the both will be the same?
Both will be fine. Yeah.
Okay.
So next is how to iterate through the key value pairs of dictionary. Till now we were either taking the key or the value. Now if you want to get both, you can use the d dot items, or here also you can do, right? you just have to print key comma d of key. That is also fine. Anyway, this is, here we are going to use items method. Using that, we'll print each of the item. So what will be the output? In this case, we see here, so we have the dictionary. Here we are trying to print, okay, anyway, this is not needed for now. Items, you know already that it is going to return list of tuples, and each tuple will be key value pair from the dictionary, right? And if you use a for loop for each item in d dot items, print the item. Okay, so d dot items is list of tuple. So each item will be one tuple, correct? So when you print item, it will give us one tuple each time. So first tuple is Amrita and 14, the first item of our dictionary, and the second one Babu and 15, the second item, and the third one Kavita and 16. So that is the third tuple that we are getting. So this is how you can iterate through the key value pairs of dictionary. Getting it?
Yes, ma'am.
No, so this d dot items, this is the tuple of these elements in the keys in the dictionary, key value pairs, right?
D dot items, it will return the tuple, yeah, list of tuple from this particular dictionary. So see, this is how it will be. D dot items will return a structure like this, list of tuples. Okay. Now, I think operations are almost over. This we have already discussed, right? Key should be unique and immutable. Yeah. Can we take a break for 5 minutes?
Okay, ma'am.
Yeah, let's continue. So the next part is about iterator. Okay. Have you gone through the lectures regarding iterator? I'm audible, right?
Yes, ma'am.
Yes, ma'am.
Yeah. So normally, how we iterate through some collection, we use for loop or while, right? So, for example, we have this particular collection, which means a list of fruits. And now, if I want to traverse through this particular list, I can use a for loop and just do this, just print it out. So I will get each of the element printed here: apple, banana, and cherry. And now, what we can do is, in this particular case, what's happening? We are not stopping anywhere. We start at the first element and we print each of the element till the end of the list, right? We don't have any control over to stop at next element and then just pause there, then continue if other some condition, if we made some other condition. So we have something called iterator that we can create over the collection, over the list, and then we can iterate through this element using the iterator. So how to create an iterator, you have to understand about two functions. One is iter function and the another one is next function. So you think it of like a cursor that we place just here in the first element or just before the first element. Okay, so when you create an iterator, just think it is like a cursor that we place here. And when you call next function using that particular iterator, what you're gonna get is the element that is pointed by the iterator. So you will get apple first. So if I print, okay, I'm just commenting this part or leave it. Okay, so we have created the iterator for our list fruits, and this is the iterator name it. And when I call next of it, it is going to give me the first element that is pointed by the iterator. So I'll get apple as output. And now if I call the next again, the same word next, the next element, the iterator will point to the next element and you will get it if an element is present at the next position. Yes, we have an element here, so I'll get banana for the next call. Next call. Now, if you call next again, you will get cherry as output. So this is how you can use an iterator to traverse through a list of elements. So if you call again, what will happen? We get this particular error called stop iteration. Okay.
Ma'am, what is the initial value, ma'am? Like IT equal to iter fruits.
So if you see the type of iterator, so it is not having any initial value, rather it's an object. It's an object that is created over this particular list, a list iterator object. Okay. And the functions that we have in that particular object is next function, which we can use on the iterator object. So using that, we can access each of the elements.
So next is a function that
Next is a
helps you.
function. Yeah. Next is a function that is written in this particular class. So basically, in everything in Python is an object, right? So we have this particular template called classes written for all these objects. So in that, we will have the functions associated with that particular object. So for the iterator objects, we have this next function written. So you can call next over the at object of iterator. That's how it works. Maybe you won't get it now. So take it as simple. We just create an iterator that we can use to loop through the collection using the iter function, and using the next function you're going to get the each of the element. For now this is enough. Okay. Now what you can do is understand how we can use it, and if you can read or you can see the lectures of week 10, right, in the playlist, just go through that. It will be easy only. Then you will understand how this particular next function is working only on it, because this next function is written only for that particular class. That's why we are calling next on the object of iter. So iter of fruits is going to return a list iterator object. So we are calling the next function over this particular object. Are you getting little bit?
Yes, ma'am.
Yeah,
Yes. Yes, ma'am.
good. So that's about iterator. Now we'll see generator. So generator means you are creating iterator using a function, and we, instead of return in the function, we have this particular keyword called yield. So yield is going to generate some value. Okay, and the specialty of yield is yield will uh, return, or we can say not return, it will produce some value and it will pause there. Okay, and only on the next call it is going to produce again. So it's something similar to that. So now this is not a normal function, it is a generator. So instead of a return, you have to use the yield keyword. So this is going to produce this value. Okay, and then it will pause there, and only for the next call it is going to call the next yield. So I'll explain this code. So we have this gen function that is taking some limit value, and here is it is starting with n equal to 1, and while n is less than or equal to limit, what it has to do, it has to yield n into n, so squaring, and then the next yield is n into n into n cube. And here we are incrementing the value of n. So that's how the while loop will work. So one, first it will be 1, and next case it will be 2, 3, 4, so till the limit. And now in line number 8, I'm calling this function the generator with value 4 for limit. Okay, a equal to gen of 4, and now we get 4 here, and what happens is this is going to create, so if you see the type of a, it will be generator. So a is an object of generator now. Okay, because gen itself is a generator. So when you call gen of 4, this a will be object of generator. And now when you call next everything is similar to iterator. So here when you call next of a, what you will get, this particular yield for the first iteration. So it is n equal to 1 here, 1 less than or equal to 4, that is true. So we will get 1 into 1. So 1 will be printed for this particular next. And for the next, this particular next call, next of a, the next yield, that is 1 into 1 into 1 will be printed. If you see the output here, see here, this is for the first line number 12, 1 and 1. And again, if you call next, then you will get for 2. So here this will become 1 plus 1, 2, and 2 less than or equal to 4 will reach here, 2 into 2, 4. That will be printed for this next, which I am highlighting, okay? And for the next of a, we will get 2 into 2 into 2, which is 8 here. Similarly, again, here 2 plus 1 will become 3, and 3 less than or equal to limit, which is true. And we'll reach here, for the next call, we will get the value that we get here, 3 into 3. And next will be 3 into 3 into 3, 27 for this particular next. Are you getting it?
Yes, ma'am.
Yeah. So you just have to remember that yield, every time it will produce something and it will pause and it will remember the state as well. That's why the next call, it is going to the next yield. Okay, just like iterator. So iterator, every time the next is called, it remembers where it is, right? Where it is pointing to. So
Ma'am,
yield. Mm.
ma'am, here we are calling next 3 times. like printing the next item. If we do one more time, then it will get what the value 4.
Yeah, yeah. I'll just print it out.
And one more doubt, ma'am. If we remove any next from the parenthesis of print, then what will happen?
Sorry, if we
Like it's print next day and next day. If we remove the second next day from the parenthesis, so it will not execute the L n times n times n, right?
we don't know. You're saying if you add this next here, what will happen? Is it so?
Yeah, ma'am. If we add or if we remove one.
Yeah, yeah. I'll show you. It's okay. Here we are closed limit. That's why this is fine. So this is one, and this is for one here, and this is for the second iteration two. This particular two into two, and here will be 2 into 2 into 2 8. If you want to remove this and put it here, and this will be, see, sorry, 1 1 4, and this will be 8, and here we go for 3 3 into 3, and this is for 3 into 3 into 3, and this is for 4. So 4 into 4 16 is printed there, and then next one 4 cube 64. But if you print again, now we reach, now we are out of this condition, right? 4 will become 5, 5 less than or equal to limit will be a false, so we don't have the next. So that's why we get the error stop iteration. Understood? Is that fine?
Yes, ma'am.
Yeah.
Ma'am, this concept will be repeated in week 10, right?
Ma'am,
No, not exactly. I was just telling the classes and object concept will be taught in week 10. So you will get to understand from where exactly those functions are coming.
Like, ma'am, in week 5 there is like generator limit, etc., etc. Next is not given actually. That's why I was
Mhm.
just asking you.
Please, please.
Like, the concept which you're telling right now is not given in week 5 actually.
It is there. You might have missed it in this particular lecture.
Okay, okay. Sorry, I have not yet come till there. Sorry.
Yeah.
Please continue. My bad.
ma'am,
Yeah.
it's getting a little bit confusing now. Like before the like as the question you were printing six values, it was getting printed, but now it's more than six, it's still getting printed.
Ma'am, excuse me, ma'am.
Can you put your code in the chat? Yeah.
Ma'am, I am always get confused about return and print a statement, ma'am. When to return and when to print.
When to return and when to print
Yes,
while
ma'am.
writing the function, right? So return, okay, suppose we have a function, and if you want to, and if you have a specification requirement where when you call the function, you want to get some value from the function, then you have to use a return.
Example, ma'am.
Yeah, yeah.
Ma'am, what was his question, ma'am?
He is confused about using return and print.
Okay.
See here, so this is the function. This is how we define a function using def. Add is the function name, the arguments, and there is the colon. We have then what we want to do. Why we use function? If we have to uh, include some part of the code where you will repeat, or if you will use this add function, this particular block of code more than one time, then you can use a function, right? So here what I the requirement is I want to, if I pass two numbers, I want to get the sum of those numbers. Okay. And when I'm calling the function here, add 2 3, right? And okay, let me change it to something like mm, s equal to, okay. So here you see I'm calling the function. I'm calling the function by passing 2 and 3, and whatever the value that I'm getting from the function, that I'm storing in s. Okay, so if I, okay, I'll just print s afterwards. So see here, I'm calling the function, and add of 2 3 goes here. A will be 2, b will be 3, and return a plus b. 2 plus 3 5, that will be returned to wherever I called. Here I am called, so here s will be pointing to 5 now. S will have the value 5, and here I am printing the value 5. Okay, so this is where I am returning the value from the function. And suppose, okay, I'll take one more part. Suppose this is a print. Okay, print a plus b. Okay, and you see here now in this function what I am doing, again adding and printing. And is this returning anything? Is this function returning anything? No. Okay, so if I call this function with true value, and if I'm expecting here for some value, I'm not getting anything because we have not returned any value. Okay, we have not returned any value. So if you do not return anything, the final statement will be none. Return none. It will be something like return none, return no value. Okay, so that's why we are getting none here because we have not returned any particular value. So simply if you do something like this, if you do not return anything, the Python will add this none, it will return none. Okay, and in this case you can't expect the value of the sum of 2 and 3, right? You are not getting the expected value in s. So what you can understand is, if you are expecting a value when you call a function, you have to return from the function itself. In cases where you just have to print in the function, you just print, but you cannot get it outside the function. Are you getting it?
Okay, ma'am, thank
Okay.
you. Got it.
Okay.
Ma'am, can you explain the generator part once again?
Explain which part?
Generator.
Generator. Okay. So generator, here we are creating the iterator using some function. Okay. And the special keyword that we have to know is yield keyword. So here you see what yield is doing. Usually in function, when you return, that particular value will be returned and you will be out of the function. Okay. Done with the function. Now you don't have any relation with the function. But when we have a generator, what happens is, when you reach here, when you yield, it is going to pause here. It won't continue, it will just pause there, and it will remember, okay, I reached this part of the function. Okay, so in this case, when I gave limit as 4, and in the first case n equal to 1 less than a limit, and if I call the first next, then you are going to get the first yield, whatever the yield generated at the first step, yield 1 into 1, that will be the output. And only when you call the next, only then it will go to the next yield. This is 1 into 1 into 1. So that is how it works. For every it will produce the value and it will pause there. Okay, and for the next call of the next function, it will yield the next one. I mean, am I confusing with the word next and yield? So just think it like this. So when you call the next, this yield will be invoked, and again when you call the next yield will be invoked. And if you call the next again, Which line will reach?
First line with incrementing the
Hmm.
and
Yeah.
value
And then we'll,
2
Then
into
it
2
will make square of 2.
is this one.
yeah, we'll reach this yield. Getting it?
If we change the value,
Then
the n value can do 2. What is the answer will come?
Huh. So 1 1. So if you will reach the stop iteration earlier.
Got it. Thank you, man.
Yeah. One more time if you call.
Error.
Yeah. So next part is lambda expression. Again, it is related to function, okay? But lambda expression means it is like we are creating anonymous function, a function without a name. Okay. So for example, here we have a normal function, a square function. Can you mute somebody? So here you see square function. So this is returning the square of whatever we give as x, and this is returning the square. Okay. Now, when you write it as a lambda expression, a anonymous function, you have to use this particular keyword lambda, and you have to specify the argument here, and then you have to put the colon, that is the syntax, and then whatever that you return as the statement, this particular expression, you add it after the colon. You don't have to use the word return and all. You just have to first mention this is a lambda expression, and this is taking one argument, and this is returning the square of whatever that we pass. So lambda expression means it's like anonymous function that doesn't have a name. Okay. Yeah. Now, how can you call it? It's like normal function call. So here I am assigning that anonymous function into this variable square. And if you print the type of square here, what it will be? Okay, sorry, what I print type of square. You see? Again, it's a function here. So when you call square of 4, it's like a normal function call. You are going to get the output, whatever that is returned here. And it is useful in some cases where we use this functions called map, etc., where you don't have to write functions outside. If it is a small function, then you don't have to write outside. In case of square
Ma'am,
also, you see, yeah.
using lambda function, which operation can we perform? Which operation can we perform?
You can use if and all. You can check condition and then do the operation. You cannot use for directly, but you can use it using list comprehension and all. You can take a collection and use a list comprehension and then iterate over it and do something on it. Mostly, you won't be doing bigger statements inside Lambda. I mean, statements itself is not allowed, but small expressions are allowed in Lambda. So we use it only when we have a small expression as a function. So to reduce the number of lines of the code and all.
We can also use it without assigning it to any variables. Ma'am,
Please repeat.
can we use it without assigning any variable?
So in that case, it won't be useful, right? So how will you call it?
In list comprehension.
In a list comprehension and in map and all, you can use without assigning a variable. So if you, okay, I'll show you later when I discuss about map. Okay.
Okay.
Yeah. So next function is enumerate function. Okay. Let's see. Let's see the definition. Enumerate is a built-in function that helps you loop through a list and automatically keeps count of the index. Okay, so see this particular list: fruits equal to apple, banana, cherry, index equal to 0. For item in fruits, what I'm going to do, print the index and then the item, and I'm incrementing index every time. And by this, what will I get? In the first iteration, index is 0, so you'll get 0, and the item corresponding to item is apple, 0 and apple. And here I'm updating the value, incrementing the value, so I'll get 0 plus 1, 1 for the variable index. And in the next iteration, the item will be banana, and the index will be 1, 1 and banana. So is this 2 cherry. So this is how you can get the index and what the item of the list. So instead of doing this, what you can do is you can use enumerate function. Enumerate function, and if you print this, you are getting the same output here, right? Whatever that we got in the using this particular code, we are getting here. Let's see. For index comma fruit in enumerate of fruits, you are printing index and the fruit. So let's try to print enumerate of fruits.
It keeps a list of
It
tuples, I
will
think.
be, yeah, let me convert into list. Yeah, it is something like list of tuple, right? So here you can see for each element we have an index associated with it. It is starting from 0. So 0 and apple are together, 1 and banana together, and 2 and cherry are together. So when you call the enumerate over the list fruits, you are going to get something like this representation. So for each index comma fruit in our this particular object, you are printing index and fruit. Getting it?
Yes, ma'am.
Yeah. Now, uh, okay, in this we don't have control over the index, right? Can we can add one more start equal to 1. So if you do something like this, and removing this part, you can change the index value also. You can change the number to something else. I'm starting with 1 here. Now, in this case, it will be 1 apple, 2 banana, and 3 cherry. That list of tuple would look like that: 1 apple, 1 comma apple, and the tuple 2 comma banana, and 3 comma cherry. So you can change the index position also according to your wish. And we can do more than that here. And now, is that fine?
Yes, ma'am.
Ma'am,
Okay.
if we iterate, then will it give the tuple or this one in the
It
enumerate
will,
function?
it will give the tuple. So okay, I just put it inside. What happened? Enumerate.
Your double.
Calling enumerate.
Within fruit,
Here,
within fruit.
here, right? No, something is wrong.
Ma'am, within you enumerate, we can try.
Okay, here. Yeah. So it will look like this.
So what is top one for okay print? Oh, achha, first one will give a list and second one will be iterate.
Yeah, here I'm iterating using the for loop. That's why. This I'm just printing, right?
Okay, okay.
So here, once you get the enumerate object, this is going to be something like this, and that is this part. Okay, now you think it like in this particular list of tuple. Okay, and each index and fruit, each of the element of that particular list. That's why we are able to do this and getting one by one, printing index and fruit.
Yes. Yes, ma'am.
Yeah. Now we have next function, zip function. So zip function takes two or more iterables like list tuple and pairs them up element by element. Here what we paired index, right? And if we have something else, suppose we have a list of names and list of marks, and I want to pair it Ali 85, Zara 92 and Mira 78, I can use the zip function. And if I print zip of so how will it be? Just like what we saw here, how it got enumerated. Here you will see name associated with the first mark and the next one Zara with 92 and next one Mira with 78. List of tuple again. Okay, that's how zip works. These two get zipped, kind of paired up. And I can use a for loop and print it as pairs. For name and mark and this particular zip object, I'm printing name and mark. Getting it? Is that okay? When I don't get response, can I assume that it's okay? I'll move to next one.
Yes, ma'am.
Yes, ma'am.
Okay.
Yes.
Ma'am, I just joined actually. What is that zip? Zip?
Zip is like we have names as a list and marks is another list. And if you want to pair it up, then you can use zip function passing the iterable list. And then it will get something like this, where you'll get list of tuples, where each tuple will be the first element of name and the first element of marks. Similarly, this particular relation. Ali 85, Zara 92, and Mira will be
Okay.
associated with 78. Yeah.
Okay, got it.
Next, next function is map function. This is a very important function. Map function is used to apply a function to every item in an iterable. Okay, let's see. So here we have numbers list 1, 2, 3, 4, 5, and here we have a function square that takes a some number n and square it. Okay, and it will return square of the number. And my requirement is I want to get the square of each of the numbers in this particular list. Okay, what I can do, I can use this particular function called map, or normally what we will do, we'll use a for loop and we'll call square function over each of the element, right? For I in nums, square of nums of I, right? Or just I, sorry, square of I. And instead of that, what you can do is you can use a map function, and what it will take, the arguments for the map function is you have to pass which function you have to apply to each of the element in the iterable in this particular list. So I want to apply the square function. Here we have the square function. I want to apply to each of the element in the nums list. So what will happen? Square of 1, square of 2, square of 3, square of 4, square of 5, and finally I'll get the result like this. 1, 4, 9, 16, 25. Again, I have to convert that to list. Okay, list of result will be list of squares because we got it here. Getting it? What we did? We applied the square function over.
Basically, nums is iterating over. Sorry, map is iterating over nums.
Yeah, kind of. Map, what it is doing, it is taking the square function and applying it over each of the element of the particular list, one by one.
Ma'am, if we pass any argument in a square function within the result, then it won't execute.
No. So here we assume that you take the argument from the list. Okay, you just have to pass the function name.
Got it.
Yeah.
Ma'am,
And
for iterating, we need to pass num, ma'am. Is it that means?
please repeat.
Means, ma'am, within the map function,
Mm.
means we are passing two there, a square and nums. Then it is necessary to it you must comes under pair.
Uh, sorry. You are saying.
Within the map function, ma'am, a
Mm.
square and nums. Ma'am, nums. It is necessary to comes in pair. Means
Not
we need
pair,
to
it
pass
should
this
be a
nums. It
collection.
is necessary.
Yeah, right. Yes, it is necessary. So map function at least need two arguments. So one should be the function, other should be the iterable, any collection. You can add more as well. So suppose, okay, in this particular case, square function is taking only one argument, right? So we are saying that take that argument from nums. Suppose we have some function that takes two arguments, then you have to pass one more, one more collection. Still we'll get the same output anyway. You got it? So what does it mean? Now what is happening? Square function, apply it over 1 from the nums and again 1 from the other list nums. So 1 into 1, n into m, that you are getting here. Clear?
Got it, ma'am.
Yeah. And can we, if we do not have this function, this is a simple function, right? Can we pass a lambda expression here?
Yes.
Yeah. So
Lambda x is that x.
lambda sum x, which returns x into x. Okay, we'll change to cube. And okay, this is the function now. This is the function that you're going to apply to each of the element in this numbers list. So this will also give the output like 1, 8, 27, 64, and 25 cube, right? We are returning the cube. Okay, this is one way of using the lambda expression in map. Mostly it will be used in map and filter.
Then we can do it in the one line also, like remove result or write in place of result, write print list map.
Yeah. Now, the last one is filter. Filter function is used to filter out items from a list based on a condition, just like the word filter. So if you want to get only the even numbers from this particular list, you can use a filter function. How we will use, we'll see. So consider this also functioning just like map, but a small difference. So here we have a function def is even, a function is even that is going to take a number and then return true or false. Okay, if it is n mod 2 equal to 0, then it will return a true, otherwise it will return a false. And this is our numbers list, and calling just like map, how you call filter, and then pass the function that you want to filter, on what basis you want to filter this particular collection. Okay, this is the function is even, and this is the collection where you want to apply this particular filtering operation. So now what will happen? The filter will return only those elements which satisfy this particular criteria that it is returning true. So what will be the output? You will get only for 2, 4 and 6. 2, 4 and 6 you will return a true, right? Here it will return a true. So only those elements will be in the result. So you'll get the output as 2, 4, 6. Getting it?
Ma'am, if we want typecast as a list, then it will return tuple.
Typecast as a list. Here we have list only, right? You want tuple?
Ma'am, if we print only result, then it will give what output?
That will be the object of filter. will print, if you simply print result, you'll get that object filter object at this particular address. So you have to typecast to tuple or list or anything to see it. Fine. All these are returning some types, some different types. If you see the type of result, again you will see it is of type filter. Okay.
Okay, ma'am.
Ma'am, can we use lambda in place of function?
Yeah, here also you can use lambda. Lambda x mod 2 equal to 0. Okay. So whenever you have some small function, you can use lambda expression. Okay, that's it
Yeah.
for today. I'll share it. I'm keeping just view access, okay? I'm not taking the doubts. I don't know. I'm getting this breathing problem. So I'm just stopping it. Okay. If you have